Good morning. It's October 4th, and this is your daily brief in science. Here's everything you need to know. New research from the University of Surrey has unveiled a crucial factor affecting dementia diagnosis: the timing of blood sample collection. This study focuses on the p-tau217 biomarker, which is essential for early dementia detection and shows significant variations throughout the day, particularly in individuals experiencing mild memory issues. Participants in the study provided blood samples every 3 hours over a 24-hour period, a method that contrasts sharply with the conventional single sample collection approach. This comprehensive sampling revealed fluctuations in 4 out of 5 measured biomarkers, with GFAP being the only exception that did not exhibit significant variation. While the reasons for these daily variations are not yet fully understood, potential influencing factors include sleep, meals, posture, activity, and circadian rhythms. Dr. Cairo Della Monica, the study's first author, emphasized the need for standardized timing and blood sample collection to improve the accuracy of dementia diagnoses and monitoring. Professor Dirk-Jan Dijk, the senior author, highlighted that understanding circadian rhythms could greatly enhance the diagnosis and treatment of Alzheimer's disease. The study involved 38 participants, including those with mild Alzheimer's, their caregivers, and cognitively healthy controls, and was conducted at the Surrey Sleep Research Center. Published in the journal Translational Psychiatry, these findings provide valuable insights into dementia research. Notably, biomarker levels for Alzheimer's were found to be lowest in the morning and highest in the evening, indicating a clear diurnal pattern. This suggests that circadian rhythms may influence the production or clearance of Alzheimer's biomarkers, although the underlying mechanisms remain to be fully elucidated. Astronomers have made a groundbreaking discovery in the field of stellar systems, identifying a unique triple star system named TIC 2900614884. This finding was achieved using artificial intelligence and data from NASA's Transiting Exoplanet Survey Satellite, or TESS. The system features 2 twin stars that orbit each other every 1.8 days, accompanied by a third star that orbits the pair every 25 days. This configuration sets a new record for the shortest outer orbital period in such systems, surpassing a previous record established in 1956. TIC 2900614884 is located in the constellation Cygnus and exhibits a nearly flat configuration, which allows for eclipses as the stars orbit. Despite their proximity, the system is considered stable, as the gravitational influences of the stars do not significantly disrupt one another. However, the formation process of this system likely hindered the development of close planetary systems around these stars. The compact nature of TIC 2900614884 enables precise measurements of the star's orbits, masses, sizes, and temperatures, which are crucial for understanding their formation and evolution. Machine learning techniques played a vital role in analyzing extensive datasets from TESS, helping to identify dimming patterns that indicate eclipses. This discovery was also a collaborative effort, with citizen scientists from the Planet Hunters project working alongside professional astronomers. Looking ahead, the upcoming Nancy Grace Roman Space Telescope is expected to enhance our understanding of stellar systems by potentially discovering larger groups of eclipsing stars. Tomasz Borkowicz, a co-author of the study, noted the unexpected nature of these findings and expressed excitement about the Romans' capability to reveal new categories of star systems. In an intriguing twist, the inner stars of TIC 2900614884 are projected to merge in approximately 20 to 40 million years, which may result in a supernova explosion. Pancreatic ductal adenocarcinoma, or PDAC, is one of the most lethal forms of cancer, marked by late diagnosis and a poor prognosis. This reality underscores the urgent need for improved diagnostic and prognostic tools to combat this disease. Most patients are diagnosed at an advanced stage, which significantly worsens their chances of survival. Researchers are now exploring liquid biopsy techniques, such as circulating tumor DNA, circulating tumor cells, exosomes, and proteomics, to enhance the diagnosis and management of PDAC. A systematic review of literature from 2019 to 2024 identified 49 studies focusing on liquid biopsy biomarkers for PDAC. Among these, circulating tumor DNA has shown potential in detecting mutant KRAS, although its effectiveness in early-stage disease remains limited. Circulating tumor cells offer high specificity, but have exhibited low sensitivity for early-stage PDAC, alongside inconsistent prognostic results. In contrast, proteomics has demonstrated superior accuracy, particularly for early detection when combined with the CA19-9 marker. Currently, CA19-9 is the only widely used biomarker for PDAC prognosis, but it has notable limitations in sensitivity and specificity. KRAS mutations, found in approximately 95% of PDAC cases, play a crucial role in determining patient outcomes. Specific mutations like KRAS-G12D are linked to more aggressive cancer, while KRAS-G12V and KRAS-G12R mutations correlate with better survival rates. Dr. Rohit Chandwani, the senior author of the study, advocates for revising clinical guidelines to include routine molecular testing for all pancreatic cancer patients, as the current guidelines only apply to late-stage cases. A study analyzing data from 1,360 patients with pancreatic tumors revealed that 29% had early-stage cancer, while the majority, 71%, presented with late-stage tumors. These findings suggest that treatment plans for pancreatic cancer patients should be personalized based on their specific KRAS mutations. This research was conducted by institutions such as Weill Cornell Medicine and Memorial Sloan Kettering Cancer Center, and was funded by the National Cancer Institute and the National Institute of Biomedical Imaging and Bioengineering. Myopia, or nearsightedness, is on the rise globally, with alarming projections indicating that by the year 2050, nearly half of the world's population, approximately 5 billion people, will be affected. This condition has reached epidemic levels in some regions, particularly in certain Asian countries where up to 88% of the population is impacted. Experts are urging a multifaceted approach to combat these rising rates, recommending increased outdoor activities, managing screen time, and scheduling regular eye exams. The surge in myopia cases is largely attributed to children spending more time indoors and less time engaging in outdoor play, which is essential for healthy eye development. Parents are encouraged to ensure their children receive regular eye examinations from an early age to facilitate early detection and intervention for myopia. Researchers at Arizona State University are working on AI-based diagnostic tools aimed at improving early detection of myopic maculopathy, with their findings recently published in JAMA Ophthalmology. Professor Yalin Wang and his team have developed new AI algorithms that classify the severity of myopic maculopathy, enhancing diagnostic accuracy. In 2015, myopic maculopathy caused visual impairment in 10 million individuals, and projections suggest that over 55 million could experience vision loss due to this condition by the year 2050. A report from the National Academies of Sciences, Engineering, and Medicine recommends reclassifying myopia as a disease to secure more resources for its management. In urban Asian communities, the high prevalence of myopia often necessitates corrective lenses for military service, underscoring the seriousness of this public health issue. Dr. Jesse Willingham has highlighted that untreated vision problems can lead to academic, social, and behavioral issues for children, emphasizing the critical need for early intervention. The rise in myopia is closely linked to increased near-work activities, such as extensive use of phones and screens, further complicating this growing epidemic. Recent research from labs in Vienna and Berlin has unveiled intriguing insights into human cellular behavior, suggesting we may possess a dormant capacity for diapause. Published in the journal Cell, this study delves into how human cells can respond to specific triggers that induce a state of dormancy, akin to embryonic diapause observed in many mammals. The researchers focused on the potential to create a pause button in human development by examining stem cells and their reactions to particular signaling pathways. By modulating the mTOR signaling pathway, they successfully induced a dormant state in human cells that mimics embryonic diapause, which is characterized by reduced cell division and slowed development. Importantly, this induced diapause state is reversible. Once the mTOR pathway is reactivated, normal development resumes, indicating a flexibility in developmental timing. According to Nicolas Rivron, one of the study's authors, this dormant capacity may suggest that humans still retain the potential to enter a state of dormancy, an intriguing evolutionary remnant. While humans do not naturally utilize diapause during pregnancy, the ability to control developmental timing could have significant implications for reproductive technologies, especially in vitro fertilization, also known as IVF. The findings imply that enhancing this control could improve IVF success rates by allowing for a longer time frame for embryo health assessment and synchronization with the mother's cycle. This discovery holds promise for advancing reproductive health treatments, particularly in enhancing the efficacy of IVF procedures. Researchers are optimistic about future studies that will further explore these findings and their implications on human reproductive health. The collaboration among these researchers underscores the importance of teamwork in tackling complex biological questions and advancing scientific understanding. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.